right, who of you guys have heard about Git before? All of you guys. That's why you guys are right here. So okay, so this talk is really meant for, and it's an introduction to Git and giving you a good feel of how to work with it with Git on a daily basis. And this morning in our session, we already showed how we are planning to integrate Git into Wakanda. So, so let me first give you a little bit of a feel for what Git is and how it works, and what the differences are to existing version control systems and other stuff. So, I'm Juergen Fesslmeier. Oh, okay. Yeah, don't worry. Yeah, I don't take it personal, huh? Okay. All right. So about Git, what is Git and who created it? So this is the guy behind Git. That's Linus Torvalds. In case you haven't known, I can really recommend this link on Bitly. It's a great video, and he talks about how Git came about and why he, is not so fond of other version control systems, of course, because he didn't create them. What he says about Git is like, I'm an egotistical bastard and I name all my projects after myself. So first is Linux and now is Git. Well, okay. There's quite a lot of projects out there in the open source that use Git. So first of all, Git itself is using Git. Linux is, of course, using Git, Perl, Eclipse, and so forth, Rails, Android, PostgreSQL is a very cool project, and of course Wakanda. So you guys can, clone your Git repository. I'll tell you a little bit later what that really is. So what is Git? The definition of Git is it's an open source distributed version control system designed for speed and efficiency. So let's decompose this. Open source because, yeah, it's open source and it's available on git-scm.com. So there you find all the links about, you get books, you get free online material, you get examples, you get the downloadable version. So just go there, install Git from here. And I really like the book there, actually. It's free. Online reading. So let's go a little bit into the history of versioning in general, right? How did we do versioning in the past or may still do it? So sometimes I do this, right, on my file system. I have a file. I right-click in the Finder and make a copy, make another copy, and make another copy. And I don't know, which copy is really the real copy. And yeah, if I lose like version history. There's no version history. I don't know what is, which copy is the real thing here. So let's up this a little bit. There was a notion of local version control systems back in the 80s. RCS is one of them. And so basically, this solves the problem, having a version database, and you keep your versions of each file in that database. So that solves the problem. You can have different versions of your file. So basically, the next step in the evolution of version control was to add a centralized way of managing versions. So you have a version control server, and you are remotely connecting to it and checking in your file, right? So in this example, Mike and Jane, they both working on a project, and they both want to work on file.m, and they are having different versions of it, each of them, and they manage it this way, right? They just check in the file, commit the file into a version control server. So problem, everything is on the server. If you're not connected, say you're on an airplane, right? You don't have access to this thing. No way you can, do all those magical things that I'm going to talk about in just a moment. So distributed version control is the next evolution. There is no centralized server. Some of those systems have been around, like BitKeeper or Mercurial. So this is nothing new. So each of the team members, Mike, Sally, and Jane, they all work with their own version, with their own repository on their file system, right? And they are synchronizing with each other, or synchronizing maybe with another repository on a server, which, you know. So Git is a distributed version control system, and in many ways, distributed version control systems combine all of those evolutionary steps from, like, flat files, versioning on the local machine to a centralized server. So this is really nothing new. But so the real big advantage is everything is local, right? All of your files in a distributed version control system, such as Git, all of that is local, almost, because, well, there are some things that you cannot do locally, or when you're on this airplane ride, right? So, so those functions are, you can, once you have a working directory of Git on your local machine, you can branch, right? You can make a branch of your own repository. You can commit to your, of course, to your own repository. You can rebase, tag, and all those things, merge, and diff, and all those things that you're really used to from version control. You can do that locally. You don't need to be connected to anything, to any network. So advantages are super fast. Yeah, pretty much everything is transparent. You can literally see what's going on in the Git folder when you do the Git commands, right? When you do a Git add. You see, it's all transparent. It's all file-based system, file system-based. Every clone is a backup. This pretty much means, like, even if you make a copy of your repository, if you're working copy on your file system, it's still a repository, right? And if you make a copy again, it's still the same repository, and you can synchronize with each other even on your own file system, or to a central system. You can synchronize with GitHub and so forth. And so you can work offline. You can work, and that's a really big benefit. So this thing, Git, is really designed for speed. And yeah, it retains the best aspects of all local and centralized version control systems. One really big aspect of Git is it is snapshot-based. So basically what that means is every file that you check in to Git is, in fact, a copy or a link, a reference to the previous version. So let's say you have file A and file B. I'm on the lower part, right? So that's what's called a snapshot. So every time a file changes in Git, there's a copy, right? So A1 has changed, so we'll copy that into the next commit. If it hasn't changed in commit 3, you just have a reference to the previous version and so forth. So the difference between this and a delta storage is delta storage only stores the differences between files. So at the beginning, at the first commit, you have your file checked in, but as you go along into different versions, you basically just get the differences between those. So how is that different from CVS and SVN, right? What's the difference between, the different version control systems in respect to, Delta versus snapshot-based versus local and distributed? So on the lower right-hand side, you see Git, so it's distributed and snapshot-based. An example of a time machine is in fact a good example of a snapshot, right? Time machine on your Mac takes snapshots after snapshot, and it's local, right? It only works when your hard drive is connected. RCS, on the other hand, it's delta storage based, so only the differences are again stored in the version control database, and it only works locally. It's never distributed. And Mercurial and Perforce, Mercurial is distributed and delta-based, so it might be behaving a little slower. And so this slide is basically giving you a good overview of the differences of all those systems out there. So just briefly, as I mentioned at the beginning, I wanted to give you a good head start on using Git. So when you get out of this session, you have never used Git, then you basically are ready to go and check in your Wakanda solution or any other files into a repository. So how do you get Git? You install it from Git SCM on Windows, or also on the Mac there are installers. On Mac, you can use Homebrew, like you do brew install Git, or use the apt package manager on Linux. It's fairly easy. Once that's done, before you start, it's a good practice to basically add your name space to tell Git who you are and how you can be reached. So this will be important later on when you work in a distributed fashion, when you basically synchronize with remotes, that your name, your files are always tagged with your name and your email address. So let's start. A new project is basically, lives in a folder, in this case project, and it has, in our case, just one file. And the important part, of course, on this slide is you do a git init. So git init creates the .git subfolder in your project folder, and in there, if you look very closely, I'm not getting into details, we'll find all those changes, all of this stuff that is going on that is transparent in there. So just do a tree on .git and you'll see what's going on. It's a hidden directory, so you will never really have to deal with it, just in case you are curious. Next thing is, in case you're working with an existing repository, you can clone a repository from a remote location to your local file system, right? The way you do it is with git clone, and you add a URL. So you might think, oh, where do I get the URL? Usually, like when you work with GitHub, it just give you every project that is hosted there, it just lists the URL you can clone from. So you just copy paste. In this case, this is our WAF framework, our client framework from Wakanda. You just clone it to your local file system, and it will live in WAF, in the WAF subfolder. Another thing you may want to take care of, on your first, commits, basically, is to exclude certain files from being in the repository. In our case, in Wakanda, you may not want to add your database, your entire database to the Git repository, right? Or you don't want to put like your ds_store files in there. So stuff that temporary files, log files, you don't need to buy. So you can just exclude those files from the repository. There's a certain syntax to it, so you just Google for it, and this is very important that you have a git ignore. Again, that's a hidden file in your project folder. So another extremely important command is, by the way, I'm completely focusing on the command line here because I want you to understand what's going on, there before we show how we integrate that stuff in Wakanda. So I think it's really important. So as soon as you have created initialized your Git repository, you want to check what the status is. So basically, the status of a new file, it hasn't been updated or added to the repository, it tells you that Git even tells you here, right, in the message, is like, hey, you may want to do a git add, right? You want to put it into the index, and that's the next step. So this is the whole workflow of using it is basically you add files to the index, and that's called staging, right? And as soon as you have staged those files or those change sets, you can then commit them. May sound, complicated or more complex at the beginning compared to when you come from Subversion, but the real advantage is there you have like a very granular way of like checking in stuff, of committing stuff into your repository. So maybe you worked on the whole day. Maybe you worked the whole day on changes, and when you never committed. You should never do that, by the way. Anyway, but you want to make small change sets to your repository. So you would just add maybe a line of code into a new commit. So maybe that becomes more clear as later on when I explain. So you can make those commits very granular. And so this one is not granular. What this does is git add. It adds every file in that project folder to your local index, to your staging area, right? And if you did a git status, it would tell you now these files are staged, right? So next step now in our workflow is do a git commit. So git commit -m means add a comment. This is our first commit, commit, and that basically puts your files that you have staged in your repository. That's all local. We're not talking about GitHub at all, or we're not talking about remote locations. This is just on your file system. Now we're getting actually into remotes. And what is a remote? A remote is a URL, right? So a remote location of your local repository requires a URL. And there are different URL types supported. Like the more common, of course, is an HTTP URL you want to add as a remote. Another one is an SSH one, like a secure protocol, or is a Git native one. There's also file and FTP ones. I've never used those. So the advantages basically between an SSH URL and an HTTP is that the SSH one is pretty neat when it comes to continuously committing to a remote location. Basically, you can upload your public key onto, let's say, GitHub, and you never have to worry about your password again, right? You just continue on pushing your sources up onto a remote location. And with HTTPS, of course, your password is not stored anywhere. You would have to re-enter it every time you want to do a push to the remote server location. So how do we create a remote repository? There are different ways. You can create a remote repository on your own servers inside your infrastructure. You can even put a remote repository on your machine and then communicate using the file URL. But nowadays, we have free service or paid services like GitHub is one of the more popular ones, or Bitbucket, Beanstalk app, and there's tons of more. So all these services basically have one thing in common. They allow you to upload your local repo to the server. So most of them, except for Beanstalk, I think, most of them you don't have to pay, right? It's open source. As soon as you push to GitHub, it's open source unless you pay. So that's their business model. But important here is Git and GitHub are completely different things. So Git and Bitbucket, they're not, of course, completely different things, but some people mix them up. They think Git is GitHub, and they're confused. GitHub is just really the service. Bitbucket is just a service for you to host remote repositories. I'm going to show you how that works on for example, on my GitHub account there. You can start from GitHub account to create a repository. Just so add your project name, some meaningful description. You can even add a default README file, and then you hit create repository, right? And that's all you pretty much need to do. I forgot to actually add another screenshot there. The next screen after this one is it gives you the server location of where your repo is available, right? So you copy again and paste that URL onto the command line to your project that you're about to publish, and you say just git add remote, and add that remote URL. So you're done. You're done with setting this up. And what really happens under the hood is inside your project in the Git folder under config, you have a remote defined here with origin. That's that's the default GitHub way. And you don't need to really be too aware of that at the beginning. Just your first publication of your repo, you have to remember that. So that's a git push -u origin space master. So master means, by the way, master means that is your, that's the branch. I'm not getting into details on branches today, but you can branch your repository, which means making different copies, different work progresses with your project, and we're working with the master. So master is the same as the trunk in Subversion. Just keep that in mind. So on your next when you push next time, so when you push again, you don't need these extra parameters. It just goes automatically. So notice also the nomenclature here. We push the repository, right? We push it, and we push it to the remote location. So the reverse is like when you want to get updates from the remote location, you pull it, right? So you do a git pull, and the git pull is really actually a merge to your local repo, and it does two things. Yeah, it fetches it and merges your repo. So anyways, as soon as you push your your repository, it's up there for everyone to see. And that's, I'm surprised. That actually, that goes for my slides. So with another 10 minutes, I could show you again basically how we integrated it. I mean, you guys have seen this morning now already in the keynote, right? So I'm not sure if it really makes sense to show it again, how we integrated Git into Wakanda. Who wants to see that again? Okay, let's show that. Yeah. So again, this is a very early version of our Git integration, and so we create a new solution here. What I want you to focus on is this dialog. Actually has the create a Git repository checkbox here. So you can imagine, so what we want to do here is like basically as soon as you check this, you get a Git init and a first commit into your repository. So we'll do a couple of things to prepare this solution for you, so you don't have to go through the ordeal on doing all this stuff on the command line, But this is not hooked up yet, so it's just in work in progress. So if it were hooked up, you would see the green lights here already, of course. In this case, we'll do. Of course, we'll also work on the menu, so those things will be a lot more easy to use later on. But so the first step here is to create the Git repo. And again, yeah, you get the green light. So that's a Git init step and a Git commit step. And also the Git ignore file has been created for you as well. So all those files that Wakanda, where you probably don't want on the repository, have been automatically ignored for you. So that has also been done. So we want to make it really easy so that the Git ignore file is in fact not even shown here. We're probably going to add an editor later on to help you make it really easy to deal with those files, with and then as you change stuff, let's actually add a JavaScript file. You'll see here, we'll indicate what that there was a change, and we may also want to work on like what are those changes, right? And then so doing like diffs and stuff, right, in the environment. And the next step would be to do another git commit, check into local, right? Add your comment, and there you go. So the plus has disappeared, so we're all good, we're all green. This is in our local repository, so now let's push this up to GitHub. And so this is sort of hard-coded. And this is sort of the notion that we want to, so we want to follow the notion of making it very easy for you guys, so you don't have to worry about all those commands, and but you need to be aware that what's going on under the hood, right? And because it really helps you in case you need to do stuff like branching, and you need to know what's going on, really. So, well, at that point, we can maybe go to my Git repository online. And here it is. There you go. Okay, so that's all I have to show today, or I'm showing today. Do you have any questions?
I often get confused between pull and fetch. There is fetch as well.
Yeah, there's a fetch at all. Oh yeah, that gets into internals, and yeah, the git fetch. If you need to refetch your repository, basically, if you have made changes and you really don't want to, yeah, there's a git fetch all, and that's really you want to actually roll back to another head in order to roll back to a previous version. So it's just Google those kinds of things that will give you the right on Stack Overflow. They give you the right stuff to the command line. But expect that to be also integrated into our, and so you want to roll back, right? So basically roll back to a previous version of your repository. So since that's a little bit difficult at times, hard to deal with, we're going to make that very easy. Sorry, I didn't get your... With merge conflicts, yeah, that's a good point. I mean, when you do this on the command line, of course, we're talking about command line, so you basically get automatic merges, but most of the times. But if you don't have them, basically the workflow works is in such a way that Git indicates the merge conflict, right? It tells in the file where the merge conflict happens. You'll get the usual, like the two versions, and then you need to basically manually say what is the real version, and then you do another git add. So I don't know. That's the technical answer. Hey, Sergey, do you want to come up and maybe talk about that to the camera? So that's also on. I get a mic or something. Yeah. So, and the short answer.
Yeah, here on it. Yes, so you can hook up your external merge and diff tools to the studio, and whenever you have a conflict, and then basically you choose you whatever. Oh, thank you. So you use whatever tool you like to merge your conflicts. You save the updated code, the resolved conflicts, and then the studio, as usual, detects that the file has been modified and will ask, do you want to reload your current file if it's open? And usually it's open because you have a conflict. So we just didn't hook it up for this particular demo, but I've tried it with 2 diff tools and merge tools that come with Git. It works. Personally, I prefer Perforce. So I've hooked up before merge for this, and it also works. So you may want to play with some additional parameters to avoid some noise. Like when I use Perforce client, it creates some temporary files when it does the merge. You may want to filter that in git ignore, but otherwise, yeah, you can use any tools you like to merge.
I was just thinking, how could we just quickly demo merge conflict, but I couldn't come up with it.
Well, it's easy to demo it. It's just that there is nothing configured. Yes, so you will see the message that there is a conflict, but nothing will be launched.
Does that answer your question, or other expectations, feedback? No? Anything else? No? Okay. Thank you very much.
Thanks.